That we were talking about the methods for expressing the attribute test conditions. So based on what the test conditions can be done to, that is what we used to look for. Now you can see the very simple thing here, that the decision tree algorithms, they provide a method of doing what you are going to take a decision, okay, or in very simple words, it is a method of establishing that marks under will be displayed by your class teacher. Okay, I will send her. If she says anything with regard to it, then I'll be displaying it, like individual wise. Otherwise, I think ma'am itself will be doing it. Okay, she will be getting to know the marks. Okay, by today, if I'm not wrong. Next, the decision tree algorithms must provide a what it method for expressing a test condition and its corresponding outcomes. So it's very in very simple words, you are going to take one condition and based on that condition, you are going to write a branches of a tree, and that branches will be representing what is known as the outcomes of that particular condition. Okay, so that is the most simplest of part. But based on what these decision trees can be drawn, these decision trees are drawn based on certain things like this. What are those? Number one, you have something called as attribute types, depending on the attribute types. Okay, next thing is depending on the number of ways the split is done. Okay, you got your attribute types and also the number of ways the split is done. So in attribute types, what and all you have binary type, you have your nominal type, ordinal type, and of course the continuous type. Okay, and in number of ways, you have two-way split or multi-way split. You can't have one-way split on them, right? Decision tree means, of course, your minimum is to have two children, left child and a right child. So depending on number of split means it's again a two-way split. Otherwise, it will be obviously the multi-way split. Okay, so let me go into this. Okay, based on the attribute types, how you are going to figure out. So you see the ones that is there in the red color, that is what you're going to represent in terms of the question. Explain the methods for expressing attribute test condition. You need to write all these things. Then you need to explain each and one of this. That's very important. Okay, so based on this, how you are going to go through. If you have to go through, this is how the binary attributes will be looking through. Okay, the test condition for a binary attribute is very much simple. Okay, because it generates only two potential outcomes. Okay, you can see the examples for it, various examples that are given to it in terms of marital status, in terms of body temperature, in terms of sex, everything is given here. Okay, so binary attributes, it will have only two types of potential attributes. This is with regard to depending on the attribute types I'm talking about. Then the next one you see is called as nominal attribute. Okay, that people need to understand that what is, first of all, you need to know what is nominal attribute, right? So that is what you can see very clearly here. The first few lines talks about what is nominal attribute. Attributes only provide enough information to distinguish one person to other person. So what are those? Okay, you have something called student roll number, the person with the sex of a person. All these things are known as nominal attribute. Okay, so what is the thing here? Since nominal attribute can have many values. Okay, what is things that you take an example of your own database. What are the various attributes that each person will be distinguished on? Whatever is roll number, different person to person, USN, different to different from person to person. Okay, take is marks, takes is native placed. Okay, takes is CET rank or the CBSE percentage. Okay, the 12th or 10th percentage. So everything is varying. Those are known as your nominal attributes. Okay, things to be kept in mind. Since a nominal attribute can have many values, its test condition can be expressed in two ways. What are two ways? One, you can do it in two ways, two-way split, or in a multi-way split. Okay, for a multi-way split, what you're going to do? The outcomes will be depending on the number of distinct values. If the number of distinct values are more, then the number of multi-way split is also more. If it's only two values, two-way split we use. If it's more values, we are going to go for a multi-way split. Okay, very simple. Next, for a multi-way split, the number of outcomes depends on the number of distinct values. Next, with regard to the marital status only, if you take, what are the various splits you can have? Three distincts you can have: single, married, divorced. Okay, any person will be falling in any one of these. Okay, it can't be like single and married. That's not possible. Okay, you can't be like married and divorced, not possible. Married or divorced, okay, that's fine. So you have to be careful with the way you're using those wordings. Okay, so you can see all those whatever the attribute that you see can be folded into these three types of categories. Okay, it's called a three-way split. You can go for a three-way split, or in general term, you can call it as a multi-way split. Okay, so in this, what's the next thing? Next thing is with regard to ordinal attribute. So you saw nominal, you saw, now you're seeing ordinal. As the name suggests, ordinal attribute means that there's some sort of an order associated with it. Okay, what is that order that you can think of? The order that you can very clearly see here is with regard to any of the values like rankings, grades, height, everything has order in it. Okay, because see, if you take off rankings, how do you do it? 1, 2, 3, 4, or if you go from bottom to up. So there's some sort of an order associated with it. Okay, again, ordinal objects can also be put in either in binary format or in multi-way format. Okay, multi-way split or a binary split. So ordinal attributes can be grouped as long as the grouping does not violate the property of attribute values. What is the meaning of violating the order of property of attribute values? Or in very simple terms, what do you mean by the property of attribute values? Is there a property like that? Yes, there is a property like that. Okay, and what do you mean by violation of it? You are going to see an example for it. Okay, you cannot violate the order of property of attribute values. Okay, what is that property? In very simple terms, this looks like this. Okay, all these things are, the classic examples with regard to each and every of these topics. Okay, when I take say classic example, it clearly means that majority of the places you basically find the same old examples everywhere. Okay, you see that shared size? How do you put it? You put it in some sort of an ordinal attribute only. Now, why you call this an ordinal attributes? Because we are following certain order here. What is that order? You start from small, then to medium, then to large, then to extra large, like that. Okay, the shirt size. You are talking about shirt size, and you are talking about what is known as going for a particular order here. Okay, that is something that you have to keep in mind. Next thing, again, you can see the shirt size can be put in form of a two-way split also. What's two-way split? Small and medium in one place, large and extra large in one place. Okay, or the other way of doing it, small in one place, medium, large, extra large in one place. But if you go to a third example, okay, the third example clearly says that if you go for something like, small and large, then you go put the next one, okay, medium and extra large. Okay, then you think of this as something like, it is violating the order of grouping. Okay, or in very simple terms, it is this grouping is violating the order. What order? That is what you can see very clearly, order of property of attribute values. Why it is violating? See, first what is small? Uske baad what you need to get medium. But you see a split that has been happening. First they have grouped small and then large in one place, but in between the medium should come. That medium is being grouped with extra large. See, small and medium in one place, it's fine. Rank 1, rank 2 in one place, fine. Rank 3 and 4 in one place, fine. It can't be like 1 and 3, 2 and 4. That is not possible. That is, if you are doing it, you are violating the order of attributes. Okay, order of property of attributes. This is what is known as ordinal attribute. Okay, see, each and every take you take, write an example, write an explanation of it. If there is something extra that is going to come with an explanation, please write that. That is how you need to go with the flow of answers here. Okay, next one. You can see this. The figure illustrates what ways of splitting the training records. Okay, based on the shared size attributes. Groupings 1 and 2, sorry, which is with regard to figure A and B, not a problem. They preserve the order of among the attribute values. But if we go to the last one, third one, what I was talking about, it combines the attribute values of small and large into same partition, while medium and extra large are put into another partition. This is with regard to violating the order of property of attributes. Okay, so you saw three things now: binary, ordinal, nominal. What's the next thing? Continuous. Okay, so based on the continuous values also, you can write a decision tree. So what is mean by continuous values? That's the next thing you're going to look for. These as real numbers as attribute values. Okay, they have real numbers. Now, what is the meaning of real numbers? Continuous data is a floating point time. Okay, now what is the thing to be kept in mind here? You think of something like temperature, height, weight, salary of a person. All these things are known as continuous values. How? because they can be any number of numbers between 1 and 2. Now, what is the meaning of they can be many numbers between 1 and 2? See, these things now, they generally take what is known as, in very simple words, the floating point type. 1.5, 6, 7, 8, 9, 10. 1.2, 3, 4, 5, 6, 7, like that. They take a larger number. Okay, they take a larger number, they take a floating point number. So how you can represent this? The representation of these things, the continuous attributes, okay, these test condition, everything can be constructed in form of what is known as range values. Okay, in terms of range value, you take any example, okay, any example with regard to how things can be written. Okay, an example like, person. We used to take a simple classic example of what? The example of salary person, right? Now, especially with regard to the previous examples, with regard to figuring out a salary of a person and then figuring out whether he or she will be able to repay the loans or not. What and all you can do, okay, based on that, what and all, how did you write all those values? You wrote in a very simple way. Okay, what is that simple way? You take as a example like of something like a salary. Okay, if you take an example for a salary, what is going to happen when it comes to salary? You look for a person who is you see, can you go for a what you call as a nominal attribute for it? Very difficult. Simple values, very difficult. You can go what is known as the figuring out a range values here. Now, what is the meaning of range values? People, you can say very clearly 10,000, okay, or 1,000 to 10,000, a range. 10 to say 30, then say 30 to 50, then again 50 to say 75, then say 75 to more than a lakh. You can go for a range values like this. If you go for a range values like this, it is more easier to put a decision tree compared to you taking the values right from 1000, okay, up to keep on putting a decision tree for up to 1 lakh. Is this even more practically possible? Very difficult. Okay, if you try to write a decision tree, okay, if you try to write a decision tree based on salary, okay, and then start writing a decision point, it will be coming like this. Multiple amount of things will be coming through, because each and every person will be think, if a database of say 50 people, so 50 people will be having varied experiences, varied profiles, varied designations. Okay, so it will be very difficult for you to put those numbers in a particular order. But this is a more easier version. How many orders that you have? It's only 5. So you can go with the salary like this, put those 5 decision parts like this. Based on that, you can segregate even more further. Or if there's no need, you can stop it there itself. Okay, so these are continuous values, and what you most important part here, that all these things comes with what is known as the range values. They happen under thing called as range values. Okay, these small things you should not forget. Okay, let me go back. So what are the things that you have in this? Okay, 1 second. Yeah, so what are the things that you have in this? The ones I was talking about. Okay, please mute yourself. Okay, now you can see this. The temperature, the height, weight, salary of a person can all be represented using continuous attributes. There can be many numbers in between 1 and 2. Okay, which basically means that you are going into, see, what is the meaning of 1 and 2? Between 1 and 2, you can have any numbers, between put in there. What is the meaning of that? You can have something like 1.11234 1.2432, like that. Any numbers between 1 and 2. For continuous attributes, the test condition can be constructed as a comparison test. What's a comparison test? A less than V, A less than V, or A greater than V or equal to V, and A greater than or equal to V, with binary outcomes. What's the meaning of binary outcomes? True or false? Can even be constructed like that. We saw an example, previous sessions. Income, salary income of more than 80k, true. Then very less chances that he is going to become what is known as a loan default. Less than 80k, we used to say, he is going to be a loan defaulter based on other outcomes, like whether he's a single guy, whether he's a homeless guy, and all. Okay, like that. Continuous attribute, very important for you to know. Okay, now how do you think it can be represented? It can be represented in a range query. It will be like this. Okay, what is the meaning of range query? Between this, yes or no. Between these values, yes or no. You can see this one, the multi-way split, the example I took with regard to salary, the same old example. Between 8 and 30 they have taken. Okay, anything between 8 and less than 8, put it in one place. 8 to 15 other place. 15 to 20 in one more place. 20 to 30 in one more place. How many splits? 5-way split. What do you call it in general way for a 5-way split? Multi-way split. Okay, what do you think when you go for a fair prices of 14.5? Anything more than for 14.5? If yes, good. If no, then you put it in other place. It's a binary split. Okay, these are continuous values. They have a larger number of values, but you could always put it in form of a condition or a range query. Okay, range query with outcomes. That is what they are talking about now. Okay, very important for you to sort of figure out all these sort of things. So the difference between these approaches is very simple. Okay, you see one as a binary split, other one as a multi-way split. Okay, based on this, you need to keep on writing the values of it. Okay, what is all these things? This is entire thing. See, you learn two things here. How a decision tree is basically being split. Okay, and you told they are split based on the attributes. Okay, then you told about the 4 points. Then you even told them that they can be even split in the ways that can be split. They can be going for a binary split, a basic split, or a multi-way split, which is a larger split. So all the three, 4 types in there and 2 types with regard to it, everything you explain. Okay, how it can be split? The answer is fine now. Okay, what's the next thing? Next thing is for the binary split, you can see very clearly the algorithm must consider all possible split positions B. Okay, it selects one that produces the best partition. Fine. For a multiply split, what does it do? It considers all possible range of continuous values. Okay, between yes or no, you are choosing only one. Between a multi-way split, you are not choosing yes or no. You're choosing, you're putting all those values in form of range values. Okay, there's no yes or no there. Okay, that's the first point. Second point, to understand the wordings of it. Okay, then you go into the next one, which is with regard to how do you determine the best split condition. Okay, which is what is the meaning of determine the best split. See, in the previous thing, you figured out to know how do you split it. Now our job is to make sure that we find how do you split it in a better way, or in very simple terms, how do you split it in a best way. Okay, not better, best way. First you saw how you are going to split it. Now you're checking, okay, in this splitting, which is my best split, how to determine the best split condition. For this, you can see there are many methods. And for methods, all these methods, outcomes of all these methods will be depending on the attributes what you do. Okay, the method used to define the best split will be giving you different decision trees. Okay, many measures are there to determine the best split of decision tree. Okay, what's the next thing? They are defined in the class distribution of records before and after splitting. What is the one thing that becomes very important here? It's called the best splitting is one of the more purity after splitting. So what is the meaning of purity? Okay, what is the meaning of purity? What is the meaning of impurity? That is those small things you're going to learn here. Okay, very important terminologies, especially for your analytics, data science, machine learning aspects of it. Is the one that has more purity after splitting. Okay, which means that you are going to split in such a way that the disorder in it is very less. Purity ka matlab the disorder in a database is very less. Okay, that is what is known as a purity aspect of it. Now you can see the entire thing. If you were to split D into smaller partitions to the outcomes, okay, ideally each partition of the splitting would be pure. What is the meaning of that? All the records fall into a given partition would belong to same class. That's a meaning with regard to purity. But you will not get to know from the wordings that are used. Okay, instead of defining the split's purity, the impurity of its child node is used. Okay, we are going to take examples for it. We are going to learn about purity, impurity, everything, and also we are going to look into the number of commonly used impurity measurements, which is with regard to entropy, Gini index, classification error, all those things you are going to learn. Okay, of course, not in detail. Again, I'm saying it's not in detail. Terminologies need to be known because it's an answer that needs to be written under data mining. But in detail, in full depth, if you want to know, you have to wait for the next semester. Okay, I think in machine learning, you are going to learn all those things in depth. What is entropy? What is Gini index? Everything you're going to learn in depth of it. Okay, very important for you to keep these tough things in mind. Okay, so let me take the first example. Okay, let me take the first thing, which is with regard to entropy. Right, what's the meaning of entropy and all? I think we are going to take one small example for each and everything, and I'm going to talk about the terminologies of it. Those terminologies need to be put in your answer. Okay, in depth there's no need in this one, but if you are really interested, you could always go learning in depth of it. It's a terminologies which you see way back into your statistics, machine learning, data science, everywhere. Okay, so let me go back into a screen and figure out what is the meaning of entropy and all. Okay, in very simple terms, I'll try to figure out what is the meaning of entropy. Entropy will be giving you, see what is the name of it? It's called entropy. Okay, what's the meaning of entropy? Entropy in general will be giving you what is known as a measure of disorder. Okay, a measure of disorder is what it will. So what is the meaning of disorder? If there is a high amount of entropy, high amount of disorder. What is the values that you are going to get? The value of entropy will be between 0 and 1 only. It will not be anything, anything else. It will be between 0 and 1 only. Anything, a value which is almost closer to 1 indicates high entropy, no doubt, and it will also indicate high disorder in the data. What's the meaning of disorder? That it's not been ordered in a proper way, or the split has not happened in a proper way, or the data is fully put in a way that it is not coming into or falling into one equal space or to a majority of the equal pace. Okay, for this, and anything closer to the a value that is anything closer to 0 indicates that it is with regard to low disorder. Okay, low disorder means that the data is almost very pure, very pure data. That's the meaning of this. Now, if I take one example, okay, think that see what are the values that you can have. First of all, I'll take two examples. I'll take one example, very simple example only. Don't want a very big example. We'll take a small example. The small example is with regard to values of take a 10 values. Okay, take 10 values. In this 10 values, any values, okay, it can be like x1, x2, x2, 10 values. In this, think that there are 3 which are positive. Okay, obviously other ones should be there. There are 7 which are negative. Can it be anywhere other than this? No. Okay, positive matlab next one will be negative only. They can't be having positive, negative. Those sort of things are not there. Okay, male, female, like this. Okay, very few amount of values that are possible. So 7 are negative. So based on this, how do you figure out the entropy of it? Okay, based on it, how do you figure out the entropy? The entropy formula is very important formula. Okay, you are going to learn all these things in science, and it's under a lab program you will learn. Okay, so entropy, the formula of ES is given view like this. Okay, be careful. You are going to figure out the summation of the values from 1 to 1 to the last value. Okay, the 1 to the last value you are going to figure out. You can write any value. Okay, you can write 1 to last. Okay, or if there is an order like that, you can have 1 to n. Okay, minus pi log 2, be careful, log 2 of again pi. Now, what is the meaning of this? What is this pi? Some people ask to know, so we'll start wondering what is this pi? Pi is nothing but the probability frequency. What is a probability frequency? Very simple. What is the probability? I'll take this example itself. What is the probability of having a positive number among these 10 numbers? Must be knowing probability. Long back you studied in third sem. Okay, under DMS you have known this. The probability of having a positive number is nothing but 3 out of 10, correct? Because there are 10 numbers, 3 out of 10. The probability of having the negative number is 7 out of 10. So this Pi is nothing but probability of having a what? Frequencies of these values. Probability frequency is what you call it. So if I want to figure out this with regard to this example, if I want to figure out entropy with regard to this example, if I can apply this formula, okay, right in here, then you will be able to get that entropy value. I think the entropy value will be more only. Why? Very simple. Because you can see, if it is something like 5 positive, 5 negative, the entropy value is almost equal to 0. Why? Because it's a very, very less disorder. Almost equal values you have. Almost equal values only, na? Almost equal values you have. But here we have it in a possibility of 30-70. 30-70 is very much, compared to this one, this is having high disorder. Okay, like only 3 people in here, 7 people are coming here on it. Okay, so this will be having higher disorder. So if I put these values in here, in this formula, how do you think it will be? Very simple. Okay, you have to just put each and every values that you have it here. Okay, if what is going to happen here, that will be equal to, see this E of S. Entropy value of set S. Okay, or anything entropy of S. If you don't want to name it as S, entropy generally we write as entropy of S. Okay, how do you think it will be? It will be very simple. See this minus, that minus will be coming here. Okay, first value, what is it? Positive. So 3/10. Okay, first is all done. Log 2. I'm sure you must be knowing how to figure out log values. Okay, why? Because it's using calculator, anyone can do. You don't have to know it manually also, but if you learn it manually, it will be really helpful. Okay, really helpful. Make sure that you're learning how to figure out log values manually, especially in terms of your placements of aptitude, mathematical aptitude. If you can know this value, do it in try to do everything without calculator. Only when when you can't do it, then only go for calculator. Okay, otherwise try to figure out some or other method to figure out for figuring out the values without any use of calculator. Now you see this, once is done, log 2 of pi, again log 2 of pi, I've written that. Okay, then again minus, because why it's again minus? Because you're talking about summation, so you're going to go with the same old minus. If it would have been plus, what do you used to write? Plus, you used to add up everything, right? Okay, you used to add up everything, same thing, only it's because it's minus, I'm going to write as minus. Okay, if you get that, what is the value that you get for the next one? 7 out of 10, because this is with regard to negative. Okay, log 2 of again 7/10. And when you sort of do this, okay, when you sort of figure out what is the values of all these things, you get approximately the value close to around 0.877, something like this, or in very simple words, almost 0.88. So you can say that the entropy is more, and you can even say that because the entropy is more, there is high order of disorder or high disorder. This you can say very clearly. Okay, this is with regard to entropy values of this. Like this, your various values. See, there is no need for you to do all this calculation, show all this calculation. You have to know the terminologies. You have to show the terminologies. Formula should be known. Okay, because you are going to write this under the topic called as what? How do you figure out my best split? Okay, for this is what you're talking about. You are talking about the various terminologies that will be used, and based on these terminologies, I can say that a particular split can be done. What is the meaning of split? How I can split the decision tree. That's all, nothing more here. How I can split the decision tree? What is the criteria that to have it? Okay, which criteria I need to take so that I'll have a very good split. Okay, very good split means very good decision tree. Very good decision tree means a decision tree that will be able to give me a better efficiency in terms of deciding things. Okay, this is very important. Okay, so you got to know what is entropy and all. Like this, you have various other terminologies. You have what is known as Gini index, Gini, Gini index. Okay, and then you are going to come across the various other terminologies. So let me go back. I think it's already time. Okay, so what are the things that you have? Okay, if you want to find the best split among yours, we need to figure out the impurity measure P before the splitting. Then we are going to compute the impurity measure M after splitting. Okay, what is impurity measure? Everything we're going to take one example and we'll do it. Okay, compute the impurity measure of each child node. Choose the attribute test condition that produces the highest gain. What's the meaning of gain? P minus M. Okay, what is P? Impurity before splitting, M after splitting. Or equivalently, lowest impurity measure after splitting. Any one that is having highest gain or lowest impurity. Okay, that test condition we are going to use it. Okay, before that you can see very clearly how you can figure out various aspects of it. Okay, I'll give this example. I'll always see this example. Okay, how do you take with regard to, see, initially we are considering, look into this, we are sort of considering 10 values in here. Okay, 10 values. In 10 values, we have written the 10 records of class 0, 10 records of class 1. You don't have to worry. First, you think of the first 10 customer IDs. What is the split you can do here? Okay, you got number of genders here 1, 2, 3, 4, 5, 6. So there are 6 males, 5, 6, yeah, 6 males and 4 females because I'm only taking up to 10. Okay, see, this is only up to here 10, there is 10 here. So only up to 10. So what's the next thing that you can think of? Next thing is with regard to gender. Okay, only up to here you just check. The next thing is with regard to gender. Okay, you got to know. Then the car type. You have to know how many types of splits you can have. You got one family type. Then you got sports. Is there any other split here? No, 2 things only. Then the shirt size you think of. There's small, there's medium, there's large, there's extra large. So you can have 4 types of splits here. When you go for class, the class 0, okay, 10 records of class 0, you put it very clearly that 10 records of class 0, next the 10 records of class 1. Okay, now based on that, just come down here and figure out what is the values I told you. I told you, right, you know that, number of males were 6, males, no, first one. Yeah, males were 6, females were 4. And you can see here very clearly. Gender, okay, class 1. Can you hopeful to see it? Okay, see this class 0, males 6, females 4, no problem. Then the car type, okay, there were only 2 types of cars. So the first one CO, okay, we had 1, there were 2 or 3 types. Let's check, because family, sports, yeah, this 10th one, see, we forgot. There's one thing called luxury, 3 types of split. Okay, so CO1, sports 1, sorry, family 1, sports is 8. Then the next one, okay, which is with regard to luxury, only 1. Then the customer ID, you think of customer ID, okay, with regard to here, see this, okay, customer ID, the first one, C1, what is the values it is having? Okay, then with regard to 10, what is the values it's having? You can put all those things in form of a multi-way split like this. So among all these things, okay, you have so many types of splitting here. Which test condition is the best condition? Okay, how or which one is the best one? That will be deciding what needs to be chosen. Okay, for that only you figure out all these sort of things. Okay, once again. Okay, yeah, for those sort of things, okay, you are going to figure out all these things. Of course, you have greedy approach, all those things, but you don't have to go that deep into it. We need to figure out what is purity. Purity means the amount of split which you have done, okay, will be in such a way that you don't have to worry much about the next splits on them. Okay, impurity means more number of disorder will be there. Purity means less number of disorder will be there. Okay, like this, there are various things that you are going to look for. Okay, this is a very important question. Before we move into the next important thing with regard to known as what is known as rule-based classifier. So second very important question. The topic of this are very important because lot of things where you have to know the technical terminologies here. If know that things will be pretty easy. Okay, so